Analysis of non-inverting amplifier with feedback. Non-inverting amplifier with feedback. It is also called as a voltage series feedback connection. Voltage series feedback connection. In voltage series feedback connection, this one is op-amp, operational amplifier. Open loop gain of that operational amplifier is AOL. Is plus and minus V1 voltage and V2 voltage. Here VA input voltage VA is applied to non-inverting terminal of an op-amp. This one is a feedback network. This one is feedback network with gain is equal to beta. Gain is equal to beta. Feedback factor is beta. This one is output. A load resistance here. A load resistance RL is connected here. A load resistance RL is connected. Here we use voltage sampling. Voltage sampling. The output voltage is V0. According to feedback, if the fraction of output voltage is connected to the input of that circuit through feedback link. This is the connectivity. V0. This one is VF. This one is V0. AOL is the open loop gain of an operational amplifier, non-inverting operational amplifier without feedback. So the feedback network, feedback factor is beta. AOL is the open loop gain of an amplifier without feedback. Now calculate AOL. AOL, this one is V1. V1 is the voltage applied at the non-inverting terminal of an op-amp. V2 is the voltage applied at the inverting terminal of an op-amp. In between these two, VAD is the differential voltage between these two terminals of an op-amp. VAD is equal to V1 minus V2. AOL is equal to, without feedback, output voltage is V0, input voltage is VAD. Therefore, AOL is equal to V0 by output voltage by input voltage without feedback. Open loop gain. This is called as a open loop gain. Open loop gain of the op-amp. That is without feedback. Next one, with feedback. AF is called as gain of that non-inverting operational amplifier is equal to output voltage V0 by input voltage VA. Input voltage is VA. considering feedback network also. Therefore, input voltage is V, output voltage is V naught. EF is output voltage by input voltage VA. This is called as a closed loop gain of the non-inverting amplifier. Non-inverting. Beta is called as a feedback vector. Beta is called as feedback vector. Beta is called as feedback vector. Here, for amplifier is from left to right, analysis is from left to right. For the feedback network, analysis is from right to left. Now we will draw the equivalent circuit diagram. This one is op amp. Plus and minus. Here plus is the V1 voltage. This one is V1 voltage. This is the voltage source VA is connected to non-inverting terminal of an op amp. This one is V2. This one is V2. In between plus V1 and minus V2, differential voltage is there. Let's say that is VDI, differential voltage. VDI is present, or VID, differential input voltage. VID. Here some resistance is there, that is RI. Here also some dependent voltage source is there, dependent voltage source. The dependent voltage source is dependent voltage source. Here some output resistance is there, output resistance R naught, some dependent voltage source, AOL, open loop gain of operation amplifier into VIT, into VIT. This is connected to ground. This is connected to ground. Next one is a feedback network. Generally, feedback, this one is plus VCC and minus VEE. The feedback, this is the output stage, output voltage. At the output stage, we have to connect the load resistance RL. Connect load resistance RL. Generally, feedback network consists of resistive configurations. Resistive configurations means we use RF, voltage divider circuit, RF and R1. This RF is connected to here, and R1 is connected to another end of the load resistance RF. Finally, this one is this one. V2 is connected to V1. This is the VF voltage. This one is V0 here. With respect to ground, VA is with respect to ground. VA is the voltage source is applied to non-inverting terminal of an op amp. This is plus. Therefore, VA is equal to V1 and V2 is equal to VF and V2 is equal to VF. VID is the differential voltage. RI is the input resistance of an op amp. AOL is the open loop gain of an op amp. VID is the differential voltage applied between these two terminals, V1 and V2 terminals of an op amp. R0 is the output resistance. Now calculate. Here we made some assumptions. V1 is equal to VI. V1 is equal to VI. V2 is equal to VF. V2 is equal to VF. VIT is equal to V1 is at a positive, V2 is at into. Therefore, VID is the difference between these two voltages. V1 minus V2. V1 minus V2. VID is equal to V1 minus V2. Therefore, V1 minus V2 is VF. That is equal to V1 plus of minus VF. Therefore, feedback voltage opposes the input voltage by 180 degrees. This is the feedback minus sign indicates 180 degrees. Feedback voltage opposes the input voltage by 180 degrees. That is the reason it is called negative feedback. So feedback is called as negative feedback. Negative feedback. Because of that minus sign, minus of. We know that generally output voltage is equal to, this is the open loop gain, AOL into PID. AOL into PID. General formula. Output voltage V0 is equal to AOL into VID. AOL VID is equal to V1 minus V2. Here V1 is VI, V2 is VM. AOL V1 is VI, V2 is VM. V2 is VM. This is the V0 is the voltage applied to this network. VF is the output voltage. Therefore, according to voltage division rule, VF is equal to total voltage applied to the circuit is V0. VF is equal to total voltage applied to the circuit is V0 into this resistance R1 by sum of these two resistances R1 plus RF. VF is equal to V0 into R1 by R1 plus R. AOL VA VF is equal to V0 into R1 by R1 plus R. R1 plus R. Therefore, V0 is equal to AOL into VI minus AOL V0 R1 by R1 plus R. R1 plus R. Bring this expression here. V0 plus AOL V0 R1 by R1 plus RF is equal to AOL into VA. Here V0 is the common term. R1 plus RF plus AOL R1 by R1 plus RF is equal to AOL into VA. Simplification. Therefore, V0 by VI, V0 by VA is equal to AF. Gain of a non-inverting operation amplifier with feedback, that is AF is equal to AOL into R1 plus RF by R1 plus RF plus AOL into R. This is the exact formula. This one is exact. Okay. This one is exact analysis, exact formula. Next one is a practical formula, ideal formula, ideal case. Next one is ideal case. AOL R1 is far greater than R1 plus R, because generally 741 IC, the AOL, the AOL value is 2 into 10 power 5 into R1. That is greater than far greater than R1 plus R. By using this assumption, therefore, AF is equal to AOL into R1 plus RF by AOL into R1 is greater than greater than R1 plus RF. Therefore, R1 plus RF is neglected. Finally, AOL into R1 is present. Compare these two. This is the higher value. This R1 plus RF is lower value. Therefore, R1 plus RF is neglected. Therefore, AOL into R1 is present. AOL is cancelled. Therefore, AF is equal to R1 by RF, R1 plus RF by R1. That is equal to 1 plus RF by R1. This is the ideal form. One is ideal case. AF is equal to, we know that AF is equal to AOL R1 plus RF by, take a exact formula, R1 plus RF plus AOL into R1. AOL into R1. AOL R1 plus RF by R1 plus RF is the common term. 1 plus AOL R1 by R1 plus R. These two are cancelled. Therefore, finally, AF is equal to AOL by 1 plus AOL R1 by R1 plus R. We know that here, this is the feedback network consists of R1 and RF. This is the V0 voltage applied to this feedback network from the output. This is the VF voltage. Therefore, VF is equal to V0 into, this is the RF. This one is R1. This one is R1. V0 into R1 by R1 plus RF. Beta is equal to VF by V0. Beta is equal to output voltage. This is the beta feedback factor. Beta is equal to output voltage VF by V0. VF by V0 is equal to R1 by R1 plus R. Substitute beta here. Therefore, AF is equal to AOL by 1 plus AOL. R1 by R1 plus RF is the beta. This is the beta. This is the closed loop gain of the non-inverting operational amplifier decreases by a factor 1 plus AOL into beta. Or gain of an non-inverting operational amplifier decreased by a factor 1 plus AOL into beta. Next parameter is RIF. Input RIF is the input resistance of that of the non-inverting input resistance of the non-inverting operational amplifier. Non-inverting operational amplifier with negative feedback. Okay, again, draw the circuit diagram here. This one is op amp. Positive here and the negative here. This one is V1, This one is V2, VA. This one is feedback network. Feedback network consists of RF and R1. This is the ground. V2 is connected to here. This is the load resistance, RL. RL is the load resistance connected here. This one is V0. This one is V0. VF. This one is V0. AYL, both in the gain of an amplifier. This one is R0. AOL into VAD. One is RA resistance. This one is VAD. The current coming from that VA is IA, that it be IA. Therefore, RIF at the input side is equal to looking like this, VA by I. I is equal to, here are two, this is the resistance, RI. This one is V1, this one is V2. V2 is also called as the VF. IA current. IA is equal to V1 minus V2 by R. We know that IA is equal to V1 minus V2. V2 is measured with V2 is the VF measured across R1. See the V1. V1 is VA measured with respect to ground. V1 is measured with respect to ground. And V2 is measured also with respect to ground. Therefore, V1 minus V2 by RF. V1 is VA, V2 is VF. V1 is VA, V2 is VF by RF. That is equal to here VAD. V1 minus VF is VAD by R. Therefore, RIF is equal to VI by IA. VI by IA is VAD by RA. VAD by RA. Therefore, VA into RI by VID. We know that output voltage V0 is equal to AOL into VID. AOL into VID. Therefore, VAD is equal to V0 by AOL. Substitute here. Therefore, RIF is equal to VI RI by VAD is equal to V0 by AOL. Finally, RIF is equal to RI into AOL by V0 by VA. RI into AOL by V0 by VA is A. Gain of the non-inverting operational amplifier with negative feedback, or closed loop gain of that non-inverting operational amplifier with negative feedback. Already derived that expression. AF is equal to AOL by 1 plus AOL into beta. Therefore, RF is equal to RI AOL by AF is equal to AOL by 1 plus AOL into beta. This AOL is cancelled. This is RI. This one is RI. RI. Yep. Finally, RIF is equal to RI into 1 plus AOL into 8. RIF is equal to RI into 1 plus AOL into beta. The input resistance of the non-inverting amplifier, operational amplifier with negative feedback is increased by a factor 1 plus AOL into 8. Next, again, output resistance. Output resistance. Output resistance of that the non-inverting amplifier. Non-inverting amplifier with the negative feedback. Negative feedback is R1. Is R1. In order to, in op amp, this is the operational amplifier. R0. AOL into VID. This one is V0. A dependent voltage source is present here. For a dependent voltage source, for calculations of output, VI is equal to 0. VI is equal to 0 means V1 is equal to 0. Set VI is equal to 0. RL is equal to infinity. Remove load resistance from the output circuit and apply V0 at the output of that op amp. The current coming from that V0 is I0. This one is RI. This one is VI. This one is VI. VI is set to 0 means short circuited. SC short circuit. Therefore, VI is equal to 0. Set VI is equal to 0. Here, this one is V1 positive, negative. This one is V2. In between these two, VID is there. Next, this one is RF. RF is connected to here. This one is R1. R1 is connected to here. This is the PF. This voltage is V0. This voltage is V0. And remove RL from this circuit. RL is equal to infinity. Connect V0 here. V0 here. The current from that V0 is the current from that V0 is I0. At this node, I0 is divided into two currents, I1 and I2. This RI is connected to one end of that RI is connected to ground. The other end of that RI is connected to R1. Therefore, simplification. This one is RI. RI is connected to ground. This one is like that. Another end of that RI. This end is connected to ground. That means this one. Another end of RI is connected to R1. This one is R1. These two are connected in parallel. This one is RL. High input resistance in parallel with low input resistance, that is low input resistance. This one is RL in series with RA in parallel with R1 plus R plus RL. This is in series resistance now. Next one, I naught is equal to, we know that I naught is equal to I1 plus I2. I naught is equal to I1 plus I2. I2 is neglected compared to I1 because R naught resistance value is equal to 0, ideal case. Therefore, the current R naught is low value. The current I1 is direction is towards the low resistance value, not high resistance value. That is the reason I1 is more current compared to I2. Therefore, I naught is approximately equal to I1. I naught is approximately equal to I1. This is the ROF is equal to V naught by I naught. V naught by I naught. ROF is equal to V naught by I naught. It is equal to V naught by I naught is approximately equal to I1. Here, V naught is the voltage connected this point here. Another point is the AOL and VID. This is the resistance R naught. V naught is connected here, and AOL into VID is connected here. This current is I1. Therefore, I1 is equal to V naught minus AOL into VID by R naught. Therefore, finally substituted here. RF is equal to V naught by I1 is V naught minus AOL into VID by R naught. VID by V naught R naught by V naught minus AOL. VID, we know that VID is V1 minus V2. V1 minus 2. Here, V1, VA is equal to 0 means VA is equal to 0 means V1 equal to 0. Therefore, ROF is equal to V naught R naught by V naught minus AOL. V1 is 0 because VA is 0 minus V2. That is equal to V naught R naught by V naught minus into minus plus AOL into V naught R naught by V naught plus AOL V2 is VF. We know that VF is equal to V naught into R1 by R1 plus RF. Substitute that term in that equation. V naught R naught by V naught plus AOL is AOL into VF is equal to V naught into R1 by R1 plus R. VF. Therefore, V naught R naught by V naught AOL V naught R1 by R1 plus RF is beta. We know that. Therefore, V naught is the common term. V naught is cancelled. Therefore, R naught by 1 plus AOL into beta. This is the output resistance of that non-inverting operational amplifier with negative feedback, decreased by a factor 1 plus AOL into beta. Next one is bandwidth. Third one is band. Third one is fourth one. Bandwidth of that bandwidth of the non-inverting amplifier. Non-inverting operational amplifier. Operational amplifier with the negative negative feedback is small f. This is the band. Now we will concentrate on bandwidth calculations. Consider open loop gain. Open loop gain AOL is a function of f, characteristic curve AOL mod AOL of f. This one is 0. This one is large scale frequency. This is magnitude 2 into 10 power 5 1. The gain is decreases like that, constant and decreasing. And it crosses this point. Unity gain band product. This is the unity. We know that bandwidth of an amplifier defined as the band of frequency over which the gain, open loop gain of that operational amplifier is a function of f is the constant part. This is the constant up to f. Generally, unit gain bandwidth product is defined as a product of. This one is open loop configuration. Open loop configuration. Product of open loop AOL, open loop gain of that op amp at 0 Hz frequency, at 0 Hz frequency into f now break frequency. This is called as a break. In the closed loop, UGB in closed loop. Closed loop means UGB over f. F means feedback. AF into FF. This is the bandwidth with positive, with not positive, with negative feedback. These two are equal. AOL F naught is equal to AF into F. AOL F naught. We know that AF is equal to AOL by 1 plus AOL into beta. One is FF. AOL is cancelled. The bandwidth of that non-inverting operational amplifier with negative feedback is FF is equal to 1 plus AOL beta, 1 plus AOL beta into beta. F naught is nothing but bandwidth of the non-inverting amplifier without feedback. FF is the bandwidth of the non-inverting amplifier with negative feedback is increased by a factor 1 plus AOL into beta. 1 plus AOL into. Next one is total output offset voltage. Total output offset voltage V total V00 is equal to plus or minus V sat by 1 plus AOL into beta. Under closed loop condition without any feedback, this is op amp. Non-inverting, inverting terminal. This one is V1 and this one is V2. This one is V0. Output offset voltage under closed loop condition, open loop condition. Based on saturation values. Saturation values means that these are the saturation values of the op amp. Plus V set minus V set. Depends on these two values, offset voltage. And in case of negative feedback is applied, that value total offset, the desirable value is offset voltage, the output offset voltage must be 0. Ideally, practically it is not possible. That must be decreased. Therefore, total output offset voltage decreased by a factor decreased by a factor 1 by plus or minus Vsat by 1 plus AOL into beta. The analysis of that non-inverting operational amplifier with negative feedback is first one, gain AF is equal to A by AOL by 1 plus AOL into beta. RIF is equal to RI into 1 plus AOL into beta. ROF is equal to R naught by 1 plus AOL into beta. FF is equal to F naught into 1 plus AOL into beta. And finally, total output offset voltage is equal to plus or minus Vsat by 1 plus AOL into beta. These are the performance analysis parameters of that non-inverting operational amplifier with negative feedback. With this, the total analysis is complete.